Okay, so we start a new unit today, and to start off with, we're going to look at how to solve quadratic equations by factoring, which is why we spent such a large amount of time already reviewing factoring from Algebra 1. So the factored form of a quadratic equation can be found using the formula a parentheses x minus p parentheses x minus q equals 0. Of course, a cannot be 0 because that would make the whole thing equal 0. And p and q are going to represent the x-intercepts of the equation. And one thing that we're going to start talking about today is the zero factor property, and sometimes that's known as the zero product property. And so you may see that abbreviated as ZPP. For any real numbers, a and b, if a times b equals 0, either a is equal to 0 or b is equal to 0, or possibly that they both are equal to 0. So we're going to use our factoring skills that we've already mastered from previous lessons, comboed with this zero product property, and we're going to be able to solve some quadratic equations. So the first thing we're going to do is we're going to look to get our equation equal to 0. So that means we're going to Now, if you look at 12x squared minus 3x, I know that there is a common factor between 12x squared and negative 3x, and that is a 3x. So if I factor a 3x out of both of those, I'm left with a 4x minus 1, and so I have 3x times 4x minus 1 equals 0. Now, my zero product property says that if I have two things multiplied together equals 0, one of those has to be 0. So I can set either 3x equal to 0 or 4x minus 1 equal to 0. So now I can solve each of these separately. 3x equals 0, divide both sides by 3, and I get x equals 0. 4x minus 1 equals 0. If I add 1 to both sides, I get 4x equals 1. And then if I divide both sides by 4, I get x equals 1/4. So my final solution is x is equal to 0 or 1/4. Now I want to remind you that you can always check your answers to make sure that these do work. So we'll try 0 first. 12 times 0 squared minus 2 times 0 equals 0. Well, if x is 0, 0 squared is 0, and 0 times 12 is 0. And then if I have negative 2 times 0, that's 0. And 0 plus 0 is 0, so that checks out. So that one's good. Then we have 1/4. So we'll try that one as well. 12 times 1/4 minus 2 times 1/4 equals 1/4. So 12 times 1/4 is the same thing as 12 divided by 4. And so that is 3. And then I have negative 2 times 1/4, which is going to be the same thing as negative 2 over 4, which is negative 1/2. All right. Let's see here. Forgot to square the 1/4. Sorry, made a mistake. This should be 1/4 squared. When I square the 1/4, that makes that 1 over 16. So 12 times 1/16. Then I can go ahead and do the negative 2 times 1/4. That's negative 1/2 equals 1/4. Okay, so 12 times 1/16 is going to be 12/16, which is the same thing as 3/4. So I have 3/4 minus 1/2 equals 1/4, and 3/4 minus 1/2. 1/2 is the same thing as 2/4. So 3/4 minus 2/4 is 1/4. So that checks out. So both of those are good. All right. So moving on. Next one here. What we've already factored when all we can do is a GCF. But now we have a trinomial. So we have x squared minus 6x minus 9 equals 18. Our first step is still to get that equal to 0, so we're going to subtract 18 from both sides. So that's minus 27 equals 0. So now we have x squared minus 6x minus 27 equals 0. And now we can use our method of factoring out a trinomial. So I have a negative 27 on top of our diamond, negative 6 on the bottom. So looking for numbers that multiply to equal negative 27 and add to equal negative 6. And that is, of course, positive 3 and negative 9. So our factors are x plus 3 and x minus 9. And so since I'm multiplying those two numbers together to equal 0, one of them has to be equal to 0. So I'm going to set them both equal to 0. So x plus 3 equals 0, x would be negative 3. X minus 9 equals 0, x would equal 9. So my two solutions are x equals negative 3 and 9. And that's my final answer. I'm always going to put them in the order from least to greatest. Now, if we're factoring a trinomial where a is not 1, of course, the first thing we got to do is make that equal to 0. So we've got to add or subtract 13 from both sides. So I get 4x squared plus 12x minus 40 equals 0. And now, of course, my first step of any factoring problem is to look for a GCF. So I'm going to look for, I can divide all those by 4. So I get x squared plus 3x minus 10 equals 0. Divide both sides by 4 to get x squared plus 3x minus 10, and then 0 divided by 4, of course, is 0. So now I'm ready to factor that. So negative 10 goes on top, 3 goes on bottom. So I'm looking for numbers that multiply together to equal negative 10 and add together to equal positive 3. So that's going to be 5 and negative 2. So x plus 5, and x minus 2. So that means that x plus 5 equals 0, x minus 2 equals 0, so x is negative 5, and x is positive 2. So those are my solutions. X is negative 5 and 2. Alright, so moving on, I want you to recall our difference of squares formula. We did spend a lot of time on this one of those days in our factoring review. So whenever we are using difference of squares, remember when I get one side equal to 0, I never want to get my leading coefficient in front of the x squared to be negative. So I'm not going to subtract a x squared from both sides. What I'm going to do is actually make this side be 0 and subtract 81 from both sides to get x squared minus 81. Okay. Now, when I factor this, all I have to do is take the square root of x squared, which is x, and the square root of 81, which is 9, and my factors are going to be x plus 9 and x minus 9. And those are my two factors. So now, I can set each of those equal to 0. And I get x is equal to negative 9 and positive 9. So to sum that up, I have x is equal to positive and negative 9. And we're going to write it just like that. Plus or minus 9. Okay, same thing here in example B. I get x squared equals negative, I need to subtract a 529. X squared minus 529 equals 0. And the square root of 529 is 23. So I get x plus 23, x minus 23. Set both of those equal to 0. And get x is negative 23, and x is 23. So we get that x is equal to plus or minus 23. All right. Now, last part here, we are going to factor a perfect square trinomial, and this is something that is really cool to work with. So what we're going to do is we're going to first of all subtract a 26y off of both sides. So we get 16y squared minus 48y, and then we're going to add 13 to both sides. So I get 36 equals 0. So this is something to always look for. If, and this has to be the case, our first coefficient, our first term has to be a perfect square, and then our last term has to be plus a perfect square. If both of those things are true, we have a perfect square trinomial. And if 16 and 36, both of those are perfect squares, and they're both positive. So what we're going to do is we're going to factor this out. We're going to take the square root of the first one, so 16y squared is 4y. Square root of the last term, 36, and that is our term there. 4y plus 6 squared equals 0. So now that we have done that, we can solve that very simply. We can take the square root of both sides, of course, to get rid of that squared. So we get 4y plus 6 equals 0. And then solve from there. 4y equals negative 6. Divide both sides by 4, and you get negative 6 over 4, which is negative 3/2. And that is our final answer. So it is very cool whenever you have a perfect square, and it's only the case when it's a perfect square in the first term and a perfect square in the last term, and it's a plus perfect square, that you can do that. Just take the square root of the first, square root of the last, and bring them together. We'll use that quite a bit in the next lesson, so hopefully you're catching on to that. Now, here's what we got to be careful with. Not all the time will we have solutions that are real numbers. In some cases, those solutions are complex numbers. Remember, we have a real part and an imaginary part, just like we learned last unit. So, when we have a x squared equals a negative number, remember, you can take the square root of both sides to solve this. But whenever I decide to take the square root, I have to take the positive and the negative square root. So I get x equals the positive and the negative square root of negative 144, which is 12i. So my answer there is x equals plus or minus 12i. Of course, the real part of that would be a real 0. The imaginary part is positive and negative 12i. And that's my final answer. All right, if you have any questions, shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great day.